think it's near enough 1:45. So I'll start. So this talk is Jakarta EE relevant to IoT? So the answer in my view is yes. That's the end of the talk. So what I'm going to do is describe a use case that you could use for IoT in using Jakarta EE. I then have a demonstration setup, which I managed to get working at the last minute after forgetting my power supplies. And then we'll go through basically the code that builds the demonstration. So just looking at code snippets from Jakarta EE and showing how that sort of builds what we're showing at the front desk here. Luckily, it's a small room, so you'll be able to see. So this is a demonstration that we have set up. It's basically we're trying to show that using Jakarta EE, you can actually build both on device and scaling right up into a cloud type environment. So using exactly the same technology, using exactly the same runtimes, and using the same sort of coding style. So what we have here, we have a sensor node. Basically, for that, we're running on Raspberry Pis. So there's a Raspberry Pi sensor node here that's running, has a sense hat on, which has a humidity sensor built into it. So that's running, basically generating measurements of humidity in the room at the moment. And that's networked with through a switch to another Raspberry Pi here, which is acting like a gateway node, really, to take samples from the network. And it has an embedded web application of which you can view and measure humidity. And they're connected using Jakarta EE. So they are running on a Payara micro, which we'll come to, which is a runtime that supports Jakarta EE APIs or JavaEE APIs. And these things are communicating by sending network events between them. So they're using what's called CDI, and they're sending clustered events between one node and the other node. So that application that's running is using WebSockets. So with Jakarta EE, obviously you get a full range of web APIs. And that includes the WebSocket API. So that's pushing data in real time down to a browser. So, and that updates effectively a graph using HTML5 in real time. And that, again, that's currently running on Raspberry Pi, and we should be able to get it on the machine as well, on the laptop. And then for this demonstration, we also have what's marked on there as a cloud connector. In this case, it's not. If we're going to scale up to the cloud, we also do a demo that includes Microsoft Azure. But for this purpose, is what we're doing. We have used a MQTT connector, and we're pushing MQTT events. So in this case, the connector is going to be using MQTT to send MQTT messages onto my laptop. Okay, it uses a standard in JavaEE JCA, which stands for Java Connector Architecture, or API, which is a standard way to build connectors to other systems that are sort of not inherent or not supported directly in JavaEE. So for example, in this case, we have a connector to the MQTT messaging protocol. Okay. The bit we haven't got in the demonstration is, beyond that, you could then use, once the messages were off the gateway node, you can obviously then push them into, on the cloud side, into any cloud infrastructure, build up big data grids, and use all the standard enterprise technology that Jakarta EE JavaEE is renowned for, to to build a data visualization or data capture system for users. Okay. So what we're running on here, obviously most people would think that running Java EE on IoT is, obviously the answer is no. These things are big, fat, heavyweight application servers that use gigabytes of memory. They're gigabytes in size to install. But that's basically not true. I mean, that is what it was like maybe 10 years ago, but not in this day and age, really. So we're running Payara Micro. So I'm from Payara. I'm Steve Millidge, so I founded Payara. And Payara Micro is a really small runtime. So we designed it to be very simple. So there's no installation. You don't have to set up an installation, download a gigabyte of data, do lots of messing around. Effectively, you just run it on the command line, and it will bootstrap a Jakarta EE JavaEE a runtime that supports standard JavaEE applications. So it's pretty small. Jar file, it says less than 70 meg, and we keep trying to keep it down there. We're very close to 70 meg now. But we keep trying to get it down so that these slides don't have to change the slides. And it's based on the full Payara server, which originally was based off Glassfish. So it is a full application server. And we have users that are using them from very small devices right up to 100 node clusters building data grids on the cloud. So depending on the heaps usage or how you set up the heap, it can obviously scale to very large applications as well. And we basically have done a lot of work with some customers to make this design for cloud environments so that it's elastic, and also to make it for container environments so that it has a lot of capabilities in there to work in containers, including things like support for environment variable replacement. As you move a container from one environment to the next, you can change things like database URLs, those sort of things. But it's also, they say, pretty small. So to run it, you basically take the jar file, you run -jar, Payara micro jar, and then deploy what would be a standard Java EE deployment artifact. So this is what's happening on these devices. So on this one, we just have an EJB. So people don't think that people still use EJBs, but it's quite a powerful technology. And this is basically running an EJB timer beam that measures a sensor and also pushes out to the frame buffer, which is these LEDs on the front. It does that on a timed basis. It's using internally some of the code from Eurotech that does the GPIO work to access the GPIO on the Raspberry Pi. So it's taking Eurotech code from the Kura project, I believe, hacking it around a bit to get rid of all the camel stuff and just working directly on GPIO. So that's ran essentially just as a Payara micro jar like that. So like I say, so what we have one micro here running an EJB. It's measuring the sensors from humidity. We have another Payara here running an embedded browser on Raspberry Pis. And so if you'll be able to see from there. But if I effectively blow on here, you can see that obviously the humidity measurement has gone up. So I can actually put that on the screen. If I can remember the URL. Oh. Why didn't I remember to do this? Okay, so that's the same, basically accessing the Jakarta EE runtime running on the Raspberry Pi. So again, if I run that, you can see that is generating the data. Okay, so I've also attempted to run a JConsole on here, but it's not seemed to be working. That isn't going to work. So what I wanted to show was that actually these are really small. So the heap size, so I was trying to X across from my Raspberry Pi to run JConsole on the laptop, but that's not refreshing properly. So the Payara Micro, like I say, is running in about, to do this sensor is running about 40 megabytes of heat. So it's not generating a huge load or impact on the Raspberry Pi. I know that they're quite large devices in the IoT sort of world, but it's plenty small enough to run on there. So, any questions on the setup before I sort of have a briefly look at some of the code involved? No questions? So, like I said, Payara Micro itself is a runtime that supports the vast majority of what are JavaEE APIs. So it covers all the web APIs. It covers EJBs, and what we have running on the sensor is a simple singleton EJB timer. So the code is pretty simple. So we have a schedule on the EJB. It's on there, which is basically running every second, and that is running that basically a tiny small piece of code which is creating a new measurement, and it's talking to the sensor itself to get that measurement. And again, like I say, that code is some of the Eurotech Raspberry Pi code to interface to the Sense Hat. It does that, and then from the network perspective, it's using a specific feature of Payara Micro, which is an extension to CDI. CDI is component dependency injection, but it supports events. And Payara Micro has an extension to that which supports events across the network. Okay, so this outbound annotation tells the Payara runtime that this event that I'm about to fire needs to be spread around the network. And then it fires the event there in that line of code, and then that's gone. That's all the code is to measure the actual humidity. And that's essentially the application that's running on that Raspberry Pi. Just it has a slightly bit more code just to drive the display for demo purposes. Okay, which just sends basically a string out to a frame buffer. Then, say on this Raspberry Pi, we have a couple of applications running. One of them is a full web application that's driving the the graph. And again, like I say, because we're running Java EE, we don't have to use any different special APIs just to generate these web applications on the small device. So it's a WebSocket application, so it has a special annotation to declare that, which is server endpoint, which is the graph. When the browser connects to the web application, the onOpen method is initiated, and that's just basically registering that there's a browser on the session. So when we have two of them, then it just keeps track of that. There's two WebSocket connections. And then we have this method here. You can see it. So what this is observing events off the network. So it has the observes annotation, which is standard Java EE, which has observed networks of, observed events of the type of humidity measurement. And then this inbound just says it basically sucks those events off the network. Okay. Once it gets an event, it basically loops through each session and pushes down the WebSocket. Pushes down the WebSocket JSON string that represents the data from the humidity sensor. Okay, so again, all our APIs are all standard, so they're all standard APIs in Java EE, so you can build these applications quite rapidly. And then it obviously generates the graph. So the graph is HTML5. It's an HTML5 graphing component, which is pretty standard. And when it gets a JSON string, it updates the graph effectively. And that essentially becomes, that's pushes the data down. Okay. Any questions on that? No, okay. So in addition on this, on what we call the gateway node, we have another application running in a separate Payara micro. So these are like little microservices. And that is doing the connection to the cloud. So this is, or in this case, connection to MQTT broker, which is running on my laptop. So again, this is using, standard Java EE. We have a project in Payara called Cloud Connectors, which has built a bunch of connectors to messaging systems that aren't JMS, which would be the standard Java EE. So we have one for MQTT. We have one for Azure Service Bus, Apache Kafka, and Amazon SQS, Simple Queue Service. So you can get the data into the cloud quite easily using these connectors. And so there has a bunch of metadata and annotations, which is defining what's called a connection factory. So this is shows you basically the resource adapter is what we deploy, which is a standard component from Payara. You have a MQTT connection factory, and then there is the MQTT properties. So we've got the server URI. Okay. Then when we receive one of these messages again, so we have an observes again inbound. So when we get one of these network events in this microservice, it uses the connection factory and basically takes the measurement, writes it to a byte array, then pushes it out to MQTT with the publish on the test topic. Okay. And then on this laptop, I have, I don't know if you can see it, but I have, again, another microservice which is listening on that MQTT topic using Java EE and the MQTT connector and printing out the message. See if I can make that a bit bigger. I don't know why I'm using this one for. Nah. Okay, so you can see the value there, 51. And if I sort of go on that again, hopefully should go up. Okay, so it's on 64 at the minute. So that's basically just, again, a tiny microservice pulling the MQTT messages from Mosquito running on my laptop. So that's again, pushing out. So this guy is pushing out the events onto Mosquito broker running on my Linux laptop. Okay, so like I say, we have a project on Payara which is building these connectors for Java EE. And then say we have one for Kafka, SQS, Service Bus, and MQTT. So these connectors are standard what are called JCA connectors, They should work on other JavaEE runtimes like Wildfly. And they are pushing, they're basically available to use to get data off these devices, potentially straight into the cloud and things like that. That's just an example. We have done it in the past with Service Bus, but I didn't want to rely on the network to push it out to the cloud. So once you've got data off the IoT device, use Payara Micro in Jakarta EE, you can actually use then exactly the same APIs, exactly the same programming knowledge that you have to then build out the server side as well. So you can use the same Payara Micros. These two are clustered together, so that's how the events are flying between them. So even on the Raspberry Pis, they're clustering and sharing data. You could then, on the cloud, you can scale that out to a massive multi-gigabyte in-memory data store if you wanted to, with exactly the sort of same technology, the same APIs. So it would be possible to build, to scale out many hundreds of these, going through the gateway node and then pushing data up to a cloud environment and using the same Payara Micros to store that within an in-memory data grid. So if we did that on this is code that would be shown for on the cloud side. This is the code that would be used to actually retrieve data and push it into a data grid. So a data grid is an in-memory key value store. So you could say cluster all the Payara Micros up and then store all the measurements from hundreds of devices into an in-memory data store. So exactly the same on the server side as would be on the MQTT. We have what's called a message-driven bean. It's using, this case would be Azure Service Bus, but it would be the same with MQTT. And we have what's called a cache. Okay, so in a similar way, when it receives a message, it basically takes that humidity measurement from the message, creates a new collection with keyed on the sensor name, and then pushes it into a grid. And that's all the code that we require to keep that measurement against the sensor name in a in-memory, large-scale, cloud-side memory store. And to retrieve them, again, this could be used on the device as well. Jakarta EE obviously supports full RESTful web services as well. So the code to retrieve things from that data grid is essentially, is literally you basically hook it to the same grid, and when there's a GET request passing in the sensor name, you could then retrieve all the data and send it down to a client device as JSON string. Okay, so that's a demo, if you like, of real code running on real smallish devices. So why would you use Jakarta EE on these devices? Like I say, Payara Micro is small, so it's running in about 30-40 megabytes of JVM heap. Obviously, you then have a JVM overhead, but you could run maybe potentially in the future with Java 9 and JLink and Java 10, you shrink that down to exactly what you need. But it also comes with a bunch of standard APIs, so you don't have to learn, if you're new JavaEE, you don't have to learn any new technology to build for these devices. So Payara Micro itself has JPA and it has an embedded database, so that device could use standard JPA database. It comes with H2, which is an embedded one, to store and forward data just on the device locally. So you can build web applications using the standard APIs. That Payara Micro supports, JSF, which would be like a little bit heavyweight, but it supports RESTful web services, WebSockets, HTTP2, all the things that you would need to build, say, an embedded web application on web console on the device. We have JCA, so we can connect to messaging systems to get data off. So again, like I say, we have a standard out-the-box MQTT support, so you could send data via MQTT off the device. There are standard concurrency APIs in Jakarta EE, so we can build very simply asynchronous, reactive, multi-threaded applications using the concurrency APIs that come with JavaEE to build embedded applications. CDI is also standard, and that's an advanced dependency injection framework. So you can use that as well. And we also have RESTful support. So you can build RESTful endpoints on the devices to communicate with the device. It supports JAX-RS. We have JSON support. So it also has REST client support. So you could use REST to actually, as a client, to invoke other services from off the device. So is Jakarta relevant to IoT? So the answer obviously was yes. I'm hoping, that we can demonstrate it, that these are small. One of the things that we did about when we built Payara Micro was to bring the Jakarta EE / Java EE to new developers, basically. Because it's not a big application server with all the heavyweight from the past that you would think. It's basically a small runtime. So you could build, if you are a Java EE developer, you can build IoT applications running with Payara Micro. So you can build applications on small devices like Raspberry Pi, and there are some fun ones out there that we know. We know Guy's got is a remote controlled car controlled by REST endpoints running on Raspberry Pis. But from a serious perspective, there's many, probably millions of Java EE developers in the world that maybe don't want to learn new APIs to program new devices, either IoT or on the cloud. Payara Micro is basically designed to give those people somewhere, to build cloud applications, build IoT applications using the same APIs they know. Because the same code can run on that, or it can run on a huge cloud multi-thousand node cluster. So next steps, quite a little bit small on here. So we've got a download link on there. All the demo code is on GitHub on that link as well. And have a go. I mean, they say all our stuff's open source. So the whole code for this demo is open source and on GitHub. So there you go. Any questions, or anyone want to have a blow on the sensors or something? Sure. So the secret is actually not a lot of difference. Okay, so one of the big differences is Payara Micro. Well, Payara Server has an OSGI runtime underneath. Okay, Payara Micro doesn't. We use OSGI, so it has a lower overhead because of that. The Payara Server supports the full JavaEE 8 API. So there's someone in here that we don't support. We don't support any of the legacy old JavaEE, so no EGB 2.1 or any of the old things, which full server does. There's no Corba or anything on this Payara Micro, and it doesn't have an embedded JMS broker or any of the big sort of things that the full server would have. But it's exactly the same code, other than it's like a wrapper around it. We did.
And Payara Micro also has some JavaEE APIs.
So,
how does that affect the size?
So Yeah, we used to have a micro profile only. So actually, Payara Micro also supports micro profile 1.3 probably as of like yesterday, because we did a new release yesterday. We used to keep it just a Payara micro profile, and actually, which was basically only supported the micro profile APIs. We stopped doing it because the resource difference is not significant. Okay, it was a bit. So Payara Micro on a reasonable sized computer, not on a Raspberry Pi, will boot in a couple of seconds. So Payara Micro Profile boot in maybe 1.5 seconds. And the memory usage wasn't really any different. So we actually concentrate on just keeping the full set of APIs and making it as small as possible. We could do modularity, but it would be a marketing feature, not an engineering feature. So we haven't bothered. Okay, thank you very much.